Hello students. The purpose of this video is to give you a rundown of all the equipment needed to run the Zeeman effect experiment. Everything you need to do the Zeeman experiment you can see in the frame in front of you here. The Zeeman experiment consists of a bunch of components that are all mounted on this optical rail here, and the optical rail is a nice sturdy piece of aluminum that allows us to clamp all these optical components down onto for a nice sturdy and quality apparatus. So let me just run down the optical rail one by one, telling you what each one of these components do. All the way over here on the left is the electromagnet. So inside this yellow tape here is a bunch of copper windings that go around big chunks of metal. And when you run current through the copper windings using these two wires here and the power supply in the back, you get a nice strong magnetic field between the poles of the magnet, which are here and here. So that's how you generate your magnetic field, and you can run about 5 or 8 amps through the coils without getting them too warm. Right between the poles of the magnet where the magnetic field is produced is this bluish lamp, which is the cadmium lamp. So remember that the Zeeman effect is about splitting electronic energy levels in some atom. In this case, cadmium is chosen. There's reasons for that, which you can read about in the lab manual. So needless to say, the glowing blue thing is cadmium discharging through electrical discharge, and so the light from the cadmium atoms is coming out, traveling down the optical rail. But of course, the cadmium atoms are immersed in the magnetic field created by this magnet here. So the light coming down is Zeeman shifted, depending on the strength of the magnetic field. So that's sort of what's down here. Next we go to a lens, which just allows us to collect some of the light from the lamp here. Lamps are kind of difficult to deal with, especially about a meter away, because they're not lasers, the light's going everywhere. So we have a lens, as we said, to collect some of the light so it doesn't get all lost into the room. The very next component we have here is a polarizer. Polarization is a very important aspect of making measurements in the Zeeman effect experiment. And essentially what we have with the polarizer here is a little hash mark that's right here on top of this black ring. And what the hash mark is an indicator of is the transmission axis of the polarizer. In other words, light coming from the lamp whose electric field component is lined up with this little hash mark will be allowed to pass through the polarizer. Everything else will be blocked. So for example, with the hash mark pointing straight up at the ceiling, oscillating electric fields in an electromagnetic wave that have the electric field pointed up and down like this will pass. But if I turn the polarizer 90 degrees like this, those previously passing vertical ones won't pass, but now electromagnetic waves that are polarized horizontally will be able to pass. And so these will be the two settings of the polarizer, and we'll also have our eye on the little hash mark right there. The next element is so-called a Pro-Ethelon. A Pro-Ethelon is a wonderful interference device that has a resolving power of about 1 million. It essentially consists of two very parallel pieces of glass with a high reflection coating painted on the inside, and light goes in this way, and an interference pattern will come out of the Pro, and the interference pattern will be circular and it'll look very much like the logo of the Target department store, or a bullseye you might see on a target, say at a shooting range or something like that. The most important thing to know about the Ethelon is a very high resolution device. Again, its resolving power is about 1 million, meaning the wavelength to the unknown wavelength that can resolve is about a factor of 1 million. So the interference pattern will travel down this way. Then we have another lens to collect the interference pattern so it can be imaged into the eyepiece right here for viewing. But before it gets to the eyepiece, we have one more element here, which is a filter. If you look back at the cadmium source here, it's sort of like a bluish light coming out. Not all of that is from cadmium. There's some xenon noble gas inside the discharge tube to help the discharge process. There's a bunch of frequencies coming out. Cadmium is in there, but it's not the blue light that we see. Cadmium is a more red light. You can look in the lab manual. I believe the wavelength is something near 640 nanometers or so. So that's what this filter does here. It only allows the cadmium light to pass on to the eyepiece. Lastly then, of course, we have the eyepiece. So if you're in the lab, you'd sit right here, put your eyeball right about here, look down at the interference pattern coming from the Pro interferometer, which we'll look at in a minute. So in the next video, we'll zoom in a little bit more on the magnet, the polarizer, and the Pro.